The broadcast is now starting. All attendees are in listen-only mode.
Well, hello everyone. My name is Felipe Fernandez. I'll be your presenter today in this NESSE webinar entitled Entrepreneurship and Green Technologies. So we are very excited to have Tony and Jeff from Grow Bioplastics, a company based in Knoxville, Tennessee, in the U.S., working in the area of bio-based polymers. And we are really excited to have them here because we thought that this is it's a very hot topic at the moment. You know, how you can transform your research ideas, your knowledge into business that can simultaneously be financially viable, but also contribute towards the bio-based economy and a more sustainable future. I would like to welcome all of you and also thank Derek and Beyond Benign for enabling this webinar through this platform. You guys have been amazing to us, and a very warm welcome to everyone who are sparing a couple of minutes to listen to us and listen to what Tony and Jeff have to say. I'm very happy to see the list of attendees growing. So guys, you're very welcome, and we have been tailoring this webinar to you. So I hope you guys can learn from Tony's and Jeff's experience as like in front of Grow Bioplastics, and listen a bit of their trajectory, a bit of their story, their challenges and opportunities in the area of green technologies. And hopefully you can all learn some tips from them. I would like to start by talking a bit about NESSE. So not sure if all of you guys who are listening to us today are members of our network. So basically NESSE is the network of early career sustainable scientists and engineers. And we are a global movement of scientists and engineers who are connected to tackle global sustainability challenges. This idea started a couple of years ago at the University of York, and we're really excited with the fact that now we've been growing and we count with hundreds of members spread across 46 different countries. So we are truly global movement. So we connect academic researchers and young professionals, especially at the beginning of their careers, and working on or simple interest in solutions to today's most pressing sustainability challenges. So you can know more about NESSE, you can join our network and get more information about what we do through our webpage, also through our Twitter. You can follow us on Facebook as well, and there you can have a better understanding of what sort of activities we do. So for our membership, we have our blog in which you have young researchers and also senior scientists sharing a bit of their stories, and it's pretty inspirational and help us, get motivated throughout our research. We are a community that act both locally through our NESSE Sustainable Science Groups, which are groups that are tackling sustainability-related problems locally at universities and working together with their community. And we offer training sessions and participate in scientific events such as conferences. We have been being in touch and always supporting ISGC, the International Symposium in Green Chemistry, on the last 2 editions. And if you guys are participating on ACS Green Chemistry and Engineering this year in Portland, we're very happy to be there supporting the student reception. So if you are attending the student reception, there will be some NESSE people there, and you're very welcome to talk to us and get more involved, because we are a team of volunteers. So we devote a bit of our free time to talk about sustainability and build this community. So we are always willing to welcome more people. We also build partnerships with other companies working in the area of sustainability. And through our advisory board, we can also offer some sort of a mentorship in which senior scientists can help you and help you shape your career in sustainability. So I've been talking a lot about NESSE, but the highlight of today is Tony and Jeff talking about Grow Bioplastics. So I'll be now passing the. I'll just enable you guys to talk. So, hey Jeff, hi Tony. Thank you so much again for agreeing to be with us today. I know you guys have been working closely to NESSE. I mean, participating of NESSE since its beginning, and we also have been following your progress very closely. And we are very happy with your success, and we're really excited to hear more about your story and what you have to share with us today. So welcome.
Thanks, Philippe. Thank you and everyone else at NESSE for organizing this, and then to Derek and everyone at BioBenign for setting up this webinar. Tony and I are very excited to be here to share our story and some of the challenges that we've faced as young entrepreneurs in green tech.
Well, yeah, thank you so much for being here. I think, as sort of just explain to our audience today, we are expecting to be here until 7 p.m. British time, so 2 p.m. in the Tennessee time. So through this hour of webinar, we're expecting to, have a chat with Tony and Jeff and ask them some questions about, their career, their progress as entrepreneurs in the area of green technologies. And in the end, you guys will have the chance of dropping some questions and hear from them a bit of, exactly what you want to ask. So to begin with, I think something that we all want to know is to know a bit more about yourselves. We've been talking about NESSE. Now it's time to you guys talk about Grow Bioplastics and yourselves as professionals. So I'll be very interested to hear from you guys a bit about your background, about what sort of motivated you to create Grow Bioplastics, and sharing a bit of what you do as a company. And I know you guys have some slides to show to us. So in this case, I'll be transferring the screen power to you guys, so we'll be able to follow your slides from now onwards. So I transfer to you, Jeff.
Yep.
There you go, brilliant.
All right, so this is Jeff speaking. I'm the co-founder, chief science officer, and Lieutenant Beard at Grow Bioplastics. And I'm here with Tony, who is our CEO and chief Beard. So Tony and I met about 6 or 7 years ago at the University of Toledo in Ohio in the US. I was studying bioengineering for my undergraduate degree. Tony was studying chemistry, and we met in a few different ways through different extracurricular groups studying sustainability and different green technologies. And then in one of these groups that we met working on, we were working on this project that was near and dear to our hearts in Toledo. So Lake Erie suffers from toxic algal blooms almost every year, and they've been getting really bad in recent years. I know in 2014, the water quality was so poor in Toledo that the city had to shut down the drinking water, and water had to be shipped into Toledo for people to drink. And one of the main contributors to these algal blooms is nutrient runoff from farms in the Midwest region that the nitrogen and phosphorus runs off of the farms and gets into the numerous rivers that feed into the Great Lakes. And this accumulation of nutrients stimulates the growth of algae, which you can see in this infographic. The algae spreads across the Great Lakes. So we were working on this technology that would capture the nutrient runoff on farms in kind of a modified ditch. And we were developing a technology that farmers could use to harvest switchgrass and other perennial grasses. They would harvest the grasses and anaerobically digest the grass to produce biogas to run some of their farm equipment. So preventing nutrient runoff, but also generating a renewable source of energy for farms. And we actually kind of tried to package this into a business and ended up doing one of our first pitch competitions as undergrads, which we both caught the bug and wanted to do entrepreneurship later on. Another thing that Tony and I both bonded on was trying to get more students involved at the University of Toledo in sustainability. So we started a student green fund, which was a fund that was, there was a fund that was completely funded by students and controlled by students. So we were on a kind of advisory panel that would oversee the use of funds to sponsor green and sustainability projects on campus. The fund now has over $100,000 in it to fund projects on campus. And so we're really proud to have that as our legacy. But we both graduated and moved on to graduate school, and Tony's going to kind of pick it up from there.
Yeah, so I graduated in 2013 with my bachelor's in chemistry, and I started looking for places around the country that had PhD programs, because I was definitely interested in graduate school, but looking for PhD programs that offered some opportunities for, you know, business classes and going outside of the traditional chemistry curriculum. Having this bug that Jeff mentioned of learning about how you can combine science and entrepreneurship, I wanted to learn more about that. So the University of Tennessee is where I ended up in a PhD program called through a department called the Bredesen Center, which is named after one of the governors in Tennessee. But it's essentially an interdisciplinary PhD program in energy science and engineering, which is a big mouthful, but it's essentially a bunch of different students, different backgrounds, from geographers to nuclear engineers, all focused on a core set of curriculum around energy science in ways that we can learn as students to move not only our technology and science forward, but at the same time, we were also taking classes in either public policy or technology commercialization and entrepreneurship. And the goal is for us as scientists to come out a bit more well-rounded and be able to kind of speak the two languages of both science and engineering, but also business or public policy. So this was kind of like the catalyst. And the great thing about this program is that all of the work we got to do as graduate students, we did in partnership with Oak Ridge National Lab. So for those of you not familiar with the national lab system in the United States, the Department of Energy has, I think, 12 or 18, I don't remember the exact number, of labs that the government funds through the Department of Energy to do energy-related research. And Oak Ridge is one of the largest ones in the country. It's right here in Tennessee. It has the history of being one of the first labs involved in the Manhattan Project that kind of birthed nuclear energy, which is kind of one of the legacies in our area. But the great part for us is that we get to work with these world-class scientists and these world-class facilities and sharpen the science of what we were working on. And so combining that with the educational resources at the University of Tennessee, we got to take a bunch of different classes. And the way that Grow Bioplastics started really was I took a 1 credit hour independent study course about this book here, Business Model Generation. If you haven't heard of it, it's a book by a guy named Alex Osterwalder. Fantastic book. He was not a business person himself. And this book actually was his PhD project, which I'm slightly jealous of. But what it essentially allows people to do is, instead of writing the traditional 50 or 100 page business plan, you have this literal canvas that you put Post-it notes on, and you figure out what your product or science is doing and what value it offers to customers, who those customers are, and all these other pieces you kind of see in this fun drawing here of like how it all ties together. And it's something that you can iterate on very fast. And so the goal of this class was for us to learn how to use it. And that's where the first idea of taking my graduate research, which was these renewable plastics, into a business model. So I did that. The next year, they offered an extended version of the class where we had a whole team. And by that point, I had convinced Jeff that he should come down and join the same program here at Tennessee. So I roped him in with 2 other students. We put together a more robust plan, initially looking to do 3D printing of plastics that are made from renewable resources, and started doing pitch competitions. And so from there, we had joined one pitch competition that was here at the university and had some success. We won $1,000, which, you know, it's not a ton of money, but further kind of gave us that infectious itch to want to go and see what else we could do with this concept. Followed up later, I took a course in the business school, an MBA level course called New Venture Planning. And it was all about how to write an actual business plan and really plan a new business from the ground up, which I really valued in this whole interdisciplinary kind of arm of graduate education, because most of the other chemistry programs I had looked into said there's no time or room for you to take classes outside of chemistry. And I disagreed with many of them, and I'm really, you know, grateful for the opportunity that our university had to let us do this. And so from that class, one thing led to another, and we started applying to pitch competitions initially at the University of Tennessee, and then around the country, and then a few internationally. And over the last year and a half, we've won, you know, 11 or 12 different competitions at over 16 or 17 events, and bootstrapped our company to the tune of about $130,000. We recently got a $225,000 grant from the National Science Foundation, which is one of the federal granting agencies here in the United States, to further our research. And we brought on our first investor, which has been really super exciting. And so one of the great things about this is we didn't know much about business and learned a lot in the meantime, but we found that by doing competitions, you can see this picture here is an actual giant check that we had to figure out how to bring home from Texas, about going out and, as 2 scientists with no business experience, learning that we could get up on stage and talk for 5 or 10 minutes really cohesively about what the problem was that we were trying to solve with our science, and not needing an MBA to do it. And we've been able to prove that, and really think that any other student who is interested in the sciences can do the same thing. So the vision that we have for the company is that there are these linear models for manufacturing. Some of you that are in Europe may have heard the term circular economies, and that's really what we're trying to move forward. But right now in commerce, any sort of materials or chemicals that we use today generally are extracted from, you know, some virgin resource. We manufacture a good. It goes out to people who use it maybe once, and then it ends up in a landfill. If we're lucky, we may capture 10 to 20% of those materials in some sort of recycling stream, or maybe in some nations that have more kind of concentrated infrastructure, it might get burned for energy, but it's not always the most optimal use for these materials. So this is a nice infographic from an organization called the Ellen MacArthur Foundation that is focused on this concept of a circular economy, where you can see on the left and right sides here, you have biological materials, which is what we're focused on, and then technical materials on the right. And everything is a loop. And the goal is to create products or create materials that can all be returned to some raw standpoint, the cradle-to-cradle model, if you've ever read that book. And so this is what we really kind of grasped onto and built our company around. And we're obviously not the only ones doing this. Some of these companies here, Adidas, Lego, Nestle, they're all really latching onto this from not only a consumer standpoint, but because it makes good business sense to be able to take, you know, bio-based renewable materials and make their products. So Adidas is making some shoes where they're capturing waste from the oceans that would be like fish nets and things like that that would kill fish. Lego is really interested in making their bricks from plastic that is made from plants. Ford and Nestle are doing some similar things. And so we took all of this together, and our vision at Grow Bioplastics is that waste is not a burden, but a resource. We like to tell everyone that we see wonder in waste. And our first step towards that is to create biodegradable plastics from, you know, plastic waste. And so this is what we really kind of grasped onto and built our company around. And we're obviously not the only ones doing this. Some of these companies here, Adidas, Lego, Nestle, they're all really latching onto this from not only a consumer standpoint, but because it makes good business sense to be able to take, you know, bio-based renewable materials and make their products. So Adidas is making some shoes where they're capturing waste from the oceans that would be like fish nets and things like that that would kill fish. Lego is really interested in making their bricks from plastic that is made from plants. Ford and Nestle are doing some similar things. And so we took all of this together, and our vision at Grow Bioplastics is that waste is not a burden, but a resource. We like to tell everyone that we see wonder in waste. And our first step towards that is to create biodegradable plastics from, you know, organic waste resources. So when we started, we had looked at all of these different options that are out there. Chitin, which is the material from shrimp shells and crustaceans, food waste, whey from dairy, even waste paper, or organic waste from water as giant opportunities to make new materials or make energy. And what we're focused on primarily is lignin. And lignin, if you're not familiar, it is something that I've focused my graduate research on for the last 4.5 years. It's a natural polymer that's found in all trees and grasses, and it's the primary byproduct of the paper and biofuel industry. So those industries all want to get to the cellulose. So if you're not familiar with the makeup of most plants, they are 20 to 30% lignin, which is kind of the glue that holds the plants and wood together to let them grow tall. And then the rest are these 6-carbon or 5-carbon sugar chains that are cellulose and hemicellulose. And those are the things that turn into the papers and the cardboards that we're used to seeing now, or as the raw feedstock materials to make these next generation of biofuels that some of you are probably working on. And the lignin, for hundreds of years, has just been this kind of leftover stuff that is really rich in chemical functionality. It is the most abundant natural source of aromatic molecules. For those of you that are chemists or biochemists or biologists that don't see just sticks and lines here. And most of the time, this is just burned by these companies. So we really saw this huge value with our technology. And what we're doing is we take this waste lignin from these companies, which we can get for very, very cheap, and we combine it with renewable bioplastics using our kind of proprietary technology into this degradable lignin polymer pelletized plastic. And because we're using plastic pellets, and that's kind of the currency of the plastics industry, if you will, we have an opportunity to start looking at all of these different industries that have hundreds of thousands of uses and hundreds of billions with a B of dollars of commerce in plastics. And as much as we would love to sell bioplastics to everybody, we really decided to focus primarily on agriculture to start. So in agriculture, there are lots of uses for plastics, but for us, it was really latching onto the fact that their uses were always directly related to food, and sustainability goals are high on their lists. So we really wanted to be able to push into that arena. And so a quick summary of what the technology is, as you can see in these 4 pictures here, in the top left, that is actually Jeff's beautiful hands modeling a handful of lignin. It's a brown powder that looks an awful lot like cinnamon. And then we could turn it into these plastic pellets and then mold those into things like films. And our goal is initially to sell them to farmers and greenhouse managers in the agriculture industry. So I'll take a break, and Jeff's going to give you a little bit of a summary of the actual business that we're going after, and kind of give you a summary of what we've been working on there.
So just to go through one use case of how these biodegradable plastics could be used in agriculture, I want to introduce you to our friend Albert, who's a farmer in Tennessee, not too far away from where our office is located. Albert has been growing fruits and vegetables for his community for over 30 years. He grows a lot of specialty crops, which includes fruits like berries and melons, and also some vegetables like tomatoes. And a lot of farmers around the country have started using this material called plastic mulch film on their farms. And if you're ever driving through an agriculturally rich area, whether in the United States or maybe in Europe or Asia, you might see miles and miles of this plastic film. And it's primarily used to block weeds. So if you essentially have a garbage bag thickness type of film that you put over the soil, it'll keep weeds from contaminating the crops, but it also retains moisture in the soil. And the benefit a lot of these farmers see is that it'll improve their crop yields. And for a crop like cantaloupe, farmers might see an increase up to 10 times in their crop yield. But at the end of the year, because these films are made from polyethylene, the farmers have to spend a lot of time and labor and disposal costs to remove this plastic. And one of the numbers that we see in the US is a farmer will spend between $300 and $500 per acre to remove all of this plastic. And a farmer like Albert has 100 acres on his farm. So he is spending upwards of $50,000 per year just to remove the plastic film. And in the US alone, the disposal cost of this plastic film is a $250 million cost to farmers. And you may not know this, but farmers aren't making a ton of money. So any savings that we can give them is huge for their operation. So with our technology, we're able to make a biodegradable film. So the way we see that kind of coming to light is farmers can use the same equipment that they already have to implement these films on their farms. They can grow their crops the same. They can harvest them the same at the end of the year. But instead of spending weeks and lots of labor to remove the plastic, they can mix it into the soil using either tilling practices or disking practices, depending on how they're operating their farm, and slowly incorporating our materials into their soil, where they're naturally degraded by the fungi and bacteria into water, compost, and carbon dioxide. One of the really exciting things that we've been able to do over the last few years is talk to over 150 farmers and really learn what the pain points are on their farms. And so a lot of the farmers we talk to that use plastic mulch film are using petroleum-based plastics, typically polyethylene. And the reason they use these films is because they're extremely low cost, but they're not biodegradable. So there's kind of a hidden cost of all of the labor and disposal fees at the end. And so we're not the first people that have tried to propose biodegradable plastics for this mulch film application, but a lot of the materials that are available now are made from starch, either from potatoes or corn. And with this competition for a food-based resource, these materials are very expensive, typically 2 to 3 times the cost of a petroleum-based plastic. And there's a lot of issues with controlling the degradation time. So we've talked to farmers using these starch-based materials, and if they're in a very sunny region, which is typically a good place to do agriculture, these films will actually break down in extreme sunlight. It's a photodegradation mechanism. So they start to break down too quickly and will actually start to disintegrate, and then the weeds can come in, which kind of eliminates the purpose of using a mulch film. Or some of the other materials don't break down quickly enough and can even contaminate the soil and potentially damage the equipment in subsequent growing seasons. So at Grow Bioplastics, we are using a waste-based feedstock to deliver a plastic available at a very low cost. But in our proprietary process, we can actually tune the degradation time of our materials to meet the needs of farmers based on their crop rotation. And this ability to tune the degradation time is something that no one else has been able to do. And so we're really excited about having that differentiation. And so while this company started with just Tony and I, we've grown quite a bit. We brought on our first employee, Danielle, a few months ago. She's helping us study the biodegradation of some of our materials. We also have some advisors with Ryan and Ricardo kind of helping us on the intellectual property side and product development. And we're really excited this summer to bring on 3 interns, one of whom actually is having her first day today. And we've also, because Tony and I are very new to business and entrepreneurship, have recruited an active and engaged advisory board with people with experience in business, people with experience in agriculture and legal, and then also people with industry experience in plastics and R&D. And we've used our resources at the University of Tennessee to recruit a research and advisory team to help us with our material development.
So I think this would be a good spot for us to stop. I think it's a pretty robust background story about who we are and what we're doing. I know, Felipe, you said that you had more questions that you had for us. So we have some kind of backup slides that I think can answer some of those, but would like to give it back to you to kind of pick up from here.
Well, Thank you very much, Chef, and thank you very much, Tony. I think this provided us with a great overview of where you came from and what motivated you guys to create Grow Bioplastics. As you said, you identified the sort of feedstock you could use, and then in terms of like different applications, you could identify one that would be your priority, and then focus on that and deliver something which was, as I said, the idea was not novel, but you guys managed to find a way to transform your materials and your process into something unique that was like different for the market. So well done for all the great work. Well done, and congratulations for all the awards you've been winning. I think this just proves how important your work is, and yeah, keep it up with the great work. Yes, so I have a couple of questions, and I plan to have it very dynamically. And of course, I had a list of questions, but I think it would be more relevant to tackle those that can relate it to things you've been talking about now. And I would like to go back to the initial slides. You guys had like one of the very first challenges you had was, go to these pitch competitions and, sell your idea. And also, you guys mentioned that, sometimes universities, they say that the students, especially, more technical background degrees, they say they have no time to worry about business models, business plans, and innovation. And I personally think that this is sort of where lots of the potential is lost throughout, all this great mass of knowledge we have as early career scientists. And going back again to the pitch talks, I think it was important that you guys were able to not only come up with a great business plan and a great idea, but also to deliver these talks in a way that could convince the investors. And I think it's very important. We're talking about talking like communication skills and soft skills. I reckon it's very important for people who are adventuring in this world of entrepreneurship. And I would like, I think I'd like to ask you guys how you developed this, soft skills, this communication skills. If you guys could share how, some tips to our audience and our members, and basically say how you guys developed this skill and what's important for you at the moment.
Yeah, so one of the biggest skills, as you mentioned, soft skills for communication and communicating science to the public. One of the simplest things you can do is just kind of practice. And so one of the ways that we've practiced is by participating in a number of startup accelerators. So for those of you that don't know the terminology, an accelerator is a program. It can either be remote or in person, but it's to help advance a startup in their venture. So some of the startup accelerators we've done, you can see them on the right-hand side on this slide. Some of them are kind of general startup accelerators that will help any business no matter what they're trying to do. Some of them are more industry specific. So we've done some accelerators that are more focused on agriculture and learning how to communicate with people in the agricultural industry. Others have been more focused on plastics and green chemistry and clean technology and learning how to communicate to those audiences. So we've kind of taken our experiences from all of these accelerators and exposures to different audience and try to craft a narrative that we can tell to kind of any audience. And so we like to tailor our presentation to those different audiences.
No, I think that's very important. I agree with you guys that practicing is a great way to improve like overall communication. And we were talking about early career researchers, so it means PhDs, postdocs, and I think it's a very important skill to have in any sort of career you want to take. That's what it's called, like a transferable skill, right? And do you think like the universities has some sort of a role, in promoting these sort of skills, or maybe changing a bit of, the graduate programs in order to focus more on transferable skills rather than just technical background?
Yeah, so I think that's something that's really relevant, and most universities do have some person, if not an actual formalized program, to do things like this. It's becoming more and more common for there to be, emphasis on science outreach and science communication, which in some lights, you may have a professor that teaches science communication in like the journalism schools or something like that. And those people can always be really good resources. And then some universities, because they have, a role in developing new technologies through science and grant-backed research, they often want to take those technologies and bring them out to the world. And so you may have a tech transfer office or sometimes a research institute that kind of controls all of that knowledge. And they often have programs to teach researchers how to do just this, how to learn, the different skills. And so that's what we did. We started with, at our particular school, there was a program that was like a 1 hour session, one night a week for 6 weeks, that taught you all of the steps about like taking an idea and through the innovation process of, something that's on paper to what could you actually present to somebody and teach you how to communicate that. So I definitely would say that most of these universities, because of this kind of growing startup culture that there is existing and the recognition of science as a valid path for entrepreneurship, those resources are out there. And if they're not, I think organizations like NESSE have done a great job of putting together resources of where people can go to learn online for free these types of soft skills. And then many of these conferences, some of you who are in the US may recognize the American Chemical Society. The Green Chemistry Institute does a conference every year. The regular ACS does a conference every year. And each of those, there are sometimes seminars or even workshops specifically on these types of things.
No, perfect. Well, great. Thank you very much for sharing your tips. And I think it's very important to give us an overview of how you guys developed the skills you reckon you could improve and where you found those resources. So thank you so much for the response, for this reply. Now I think we can move and talk about the process itself. So we are talking about bioplastics, sustainable materials. So what sort of measures you guys have to take to ensure that your plastics are biodegradable in terms of its formulation, and also how you guys can ensure that the manufacturing process follows sustainable practices? They're following the principles of green chemistry or green engineering. So basically, what you guys do to ensure that what you're doing is more sustainable than what is already available in the market.
Sure. So this is a great question, and I'm really happy. This is something that we're actually really excited to be able to share. So on the first note, the biodegradation side of things, that's an active area that we're always working on. Our newest employee, Danielle, actually has been working in one of the academic labs with one of our advisors for the last year or so on using certain methods that are laboratory based to monitor the degradation of plastics in soil. And so there are established methods to do this. And within that, there are other kind of chemical analyses you can do to monitor soil health. And that's something that we're working on right now. And we're operating under the assumption, and some of this is still an assumption, and this I think is really valid. As a startup, we don't have it all figured out yet, but we're very confident that we're going in the right direction. Some of the bioplastics that we're using that go in with the lignin materials that we have, they already have been proven to degrade in the soil, to leave nothing behind other than water, CO2, or biomass. And then lignin itself is actually recognized as a soil amendment material to add organic carbon. So by adding the two together, we're kind of combining the best of both of those worlds. Now, the combination of the two as a plastic material itself is something we're still actively tweaking the process to make sure that we have full control over how long these take to degrade. And we feel it's our responsibility to look at the long-term impacts on soil health, if we're doing that, or in compost, kind of what those implications are. Regarding manufacturing, one of the things that we're super excited about is in the past, when people have made materials like this, they've needed to go through this process where they take lignin, because a few people have tried to make plastics from lignin before, and they need to take lignin and then put it in some sort of a chemical solvent with other additives and catalysts to modify the lignin, and then separate it from that solvent, which is really energy intensive, and then you have all of that waste solvent left over that you may or may not be able to recycle, and then combine that with other plastics to make these materials. And in our process, what we're able to do is skip that whole chemical modification step. And so our process is pretty close to zero waste. All of the raw materials that we use that go into it, using just kind of standard plastic manufacturing equipment, come out the other end in the final product. So we don't have any solvent waste. We just have, some energy input to combine all of these things together. And then ideally, any material that we produce that doesn't end up in a product is something that we can recycle back into the process, or make sure that we're, composting it on site. Hopefully maybe growing some fruits and vegetables for lunch.
No, perfect. I mean, it's very important, right, to know that you can deliver sustainability throughout the whole process of manufacturing of your product, because I think that's how you can convince investors and users to adopt your new material. So now we actually have a question coming from the audience. Because of the time, I think I'll prioritize questions coming from the participants. And this question is coming from Kleber. Kleber, thank you very much for a question and for joining us today. So the question is actually regarding the current material that is in place, the multi-film coming from the farms. Kleber is asking, how does a plastic collection works on a farm? Does it has a place where producers deliver it, or is it passed by farms collecting all plastic materials? So yeah, can you guys tell us more about how is the the supply chain of this plastic, and basically what is done with this plastic that is left on the fields?
Yeah, so from the conversations that we've had with farmers, and this is mostly in the US, so it might differ a little bit in other countries, but a lot of these farmers, they have to manually pick up the plastic, and they will usually load them on some kind of truck to take it to the landfill. So there's the labor costs associated with picking up the plastic, and there's also usually a tipping fee to bring the plastic from the farm to a landfill. And unfortunately, because these materials are being used on the farm, they're often contaminated with pesticides and herbicides, so they're not able to be recycled. There's a very low recycling rate for these plastics. So what some farmers end up doing to mitigate these costs is they will bury the plastics and kind of use a out of sight, out of mind solution, and just bury the plastic somewhere else on their field. And sometimes the farmers will even burn the plastics on their field to save some of those costs. And in the US, the fines associated with burning the film are not that high, so they're really not leading to behavior change. And I mean, we've had conversations with farmers that have told us to our face that they burn the plastic on their farm just to get rid of the plastic.
That's very interesting to understand how is the current scenario. And I think you mentioned key not word but words in your answer, which was a behavior change. I think it's a very big buzzword in terms of how sustainable materials are incorporated in the market, and that's something that makes us curious about what is the hardest thing you guys face in terms of commercializing your product or your processes. Does it the resistance? Does it come from the investors, or you think the policymakers have more resistance to encourage these sustainable materials, or even the consumers? So where is the bottleneck that you guys can reckon in this, at least in your field, in your kind of technology?
So that's a great question. And I think it's really important to share the two drivers that we see are, or that we've seen in other companies who are in like this green, sustainable, and clean tech type of space is investor understanding, which is I think a challenge for every startup. But if you go through the process and you communicate that you're solving a real problem with a well-vetted solution, that's actually a smaller hill to get over. Customer adoption, we always see as one of the larger hurdles. And so for us, because we're focused in agriculture to begin with, the way that most of the decisions among growers are made is heavily trust-based. So we are these newcomers where we don't have, neither one of us in particular has a background in agriculture. And so to break into this market, we need to make sure that we have trusted partners who have interacted with these different farmers for years. What they usually do is they look to their peers to find out what works and what doesn't. And so for us to be able to penetrate that market, we need to get some early adopters on board with us to be able to help us with things like field tests, and then get that data and those kind of positive opinions out into the market. And that's a strong focus area that we have right now. But we do see that as kind of our biggest challenge going forward is customer adoption. We're trying to mitigate that to some degree because we have the opportunity to say that, you know, if we're working with these farmers and they're not necessarily needing to change their process, the only thing that they would do differently is instead of pulling up the plastic, they just till it into the soil. The behavior change is minimal, but getting them to that point where we can confidently say these materials will work the same, they're not going to impact your crop yields, that's really important to them. So you know, we definitely have our work cut out for us, that's for sure.
And I just want to add quickly that on like the manufacturing side, we're not too concerned about behavior change because we're able to make a plastic resin that doesn't require any new equipment. So the manufacturers that are making films or gardening pots or different materials in agriculture and other industries, they can use our resin the same way that they use maybe a polyethylene resin today. So there's not a lot of behavior change needed on the manufacturing side.
No, brilliant. I think that's a very interesting characteristic of your approach, that is conserving the processes that the farmers are used, basically consumers are used to, and just giving it with a twist, right? Which is very important to get the early adopters. Now moving towards like talking a bit like more broad about green technologies and about the innovation behind green technologies. Do you guys reckon that the main innovations and the main driving force towards these innovations is coming from big companies, or do you think that startup companies and small companies like you guys are the ones in charge of bringing innovation to the market?
You know, this is a really good thing, and I think it's an important question. Historically, it was large companies. It was the Dows and DuPonts and BASFs of the world. And to some degree, they are still leading innovations in their own right. But those businesses have matured to such a stature and size that it's really difficult for them to be fast-moving and agile, and that's really important for innovation. I don't know much about the organizational structure of some of those big businesses, but I do know that they generally just can't make decisions as fast because they're kind of locked down with more of a corporate hierarchy, and they are very risk averse because they are often for-profit corporations that are publicly traded. They're public companies, so they kind of have to answer to their shareholders in the stock market and quarterly earnings and things like that. So two things that kind of go into this. From that front, there has been a strong push for these companies to develop new sort of venture arms where they are actively working with startups like ourselves who really do have the kind of, I guess, scrappiness or grit that you could say to come up with these new innovations and do it quickly at much lower costs. You know, our office is here in a, it's an old house it's a farmhouse from the 1800s. Our lab is actually in a garage. we have very low overhead to be able to do some of these things and get that out there. And these big companies look to startups like us and see which ones are successful, and then they are poised to be good partners to help us actually reach scale so we can make kind of a global impact. And then the other thing is, you can see in this slide here, there's an organization in the United States, and I don't know if they're international yet, I hope so, called B Labs, and their model is to go from a C corporation to what's called a benefit corporation. And so in addition to the opportunities for building a profitable enterprise, in the same amount of responsibility to deliver profit to shareholders, benefit corporations can also pick from some of these other key tenets of their businesses to focus on, and say, like, environmental standards. They want to dictate that all of their suppliers are making certain environmental goals, or that they're offering proper benefits for their employees, or they have a social or environmental impact that is at the same level of importance as making money. And so this new method of operating these sustainable businesses is something that we are super, super happy about, and we have plans to become a certified benefit corporation. And this is something that those big companies can't quite do. So together, I think it's kind of a long-winded answer, but succinctly, yeah, I would say a lot of the innovation is driven by small companies like ourselves. But for it to really make the big impacts that we want, we need these big companies to see us as partners and not competitors.
Oh, brilliant. I think it's really important for us to understand this point of view coming, what you guys reckon as the importance of the small and the big companies, and how they can in each way contribute towards green technologies. So in respect of the time, we're moving toward the final group of questions. And we have another one coming from the audience, coming from Glenn. So thanks, Glenn, for joining us today. So Glenn says, congrats on your success. Would you be able to provide an example of something you worked on that was less successful and what you learned from it?
Sure. So I think that a really good opportunity to talk about is kind of the learning by failing that we've done. So one of the things that we're proud of is this year we were able to get a grant from the National Science Foundation, which is an agency here in the U.S., one of the many government agencies that does research grants, and they have a program called the SBIR. It's a Small Business Innovation Research Program, and they issued grants to small businesses doing hard tech, science-based technologies, to give them funding to get the technology vetted to the point where they could go and bring it to market. So last year, we applied for one of these from the Department of Agriculture here in the United States. We were super excited about it. We had this application put together. The applications take 100 to 150 man hours to do. They're 50 to 60 pages long. And we thought that we had it in the bag. And you submit these applications, and we hear back 6 to 9 months later, and we got one email that was like, thanks for your application, but it didn't meet the requirements we had. Here's a few comments from reviewers. Try again next year. So we thought that we had this. We were super confident because we had won all these competitions, and then realized pretty quickly that there was just a large gap in how we were communicating the value of what we were doing, and that why we, as two non-business people but just technical people, would be the right ones to do this. So it was a really interesting lesson for us, and we took all of the lessons learned from that, all of the review and feedback, and submitted a new application to the National Science Foundation, and we were awarded that grant. So I would say that, especially as entrepreneurs, you are going to fail, and you're going to fail often, and that's actually a good thing, because if you don't have these failures, you're not necessarily going to be able to see the forest for the trees, sort of thing. You're going to get stuck thinking that you have the best idea because nobody's told you otherwise. So,
and I think another real quick example of something that we failed but used that failure as an opportunity to learn was very, very early on in our company. I mean, I think within a few months after starting, we got into a pitch competition in Texas called the Rice Business Plan Competition, which is one of, if not the biggest student pitch competition in the world. They give away over $1 million in funding and investment every year. And we got accepted into this competition having only had a business for a few months and not having a prototype of what our material would look like and not having developed a really robust business plan. But we got to this competition and we gave our first presentation to like a judging panel. And at the very end, they asked us how much money we would need to raise in order to get our company off the ground. And we said, I think $500,000, which to us seemed like a huge amount of money at the time. But everyone in that room kind of looked at us and said, that's it? And kind of jokingly said, like, you'll never get this company off the ground if you're only asking for $500,000. And so we realized that there were a lot of unknowns that we were unaware of at the time, and kind of came back to Knoxville after that competition and like really had to look at everything more seriously and look at all the things that we didn't understand in order to build a bigger business. And that learning experience like really helped us with our success with business pitch competitions that we did after.
I think, well, thank you very much, guys, for sharing your experience. I think it's coming from the first reply from Tony. I think it's important. Actually, it's quite interesting to link with my very first question, because it seems that you guys had a problem of, the communication skills and talking the same language as the investors, as those who were providing the grant. So you guys had to go through the process of applying to learn how to communicate your innovation in the right way. And also come from Jeff's example, building up the maturity to deliver the business in a way that is basically relevant for the market. So I think it was a great question. So, and thank you so much for sharing this experience with us. And I would like to have like a final question, which is not exactly a question, but I would like to hear from you guys. What kind of recommendations you would have for those who are listening for us now, or who will be listening to us in the future, because this webinar is being recorded. So if you guys want to then share with your friends who were not able to attend today, they'll be able to go through all our webinar in the future. So what recommendations do you guys have for those who are thinking about transforming their research ideas, their business ideas in a startup company?
So I have a two-part one, and then Jeff has one. For me, I would say that if you even have like the slightest interest or desire in doing something entrepreneurial related to your research or otherwise, and a big part is it doesn't necessarily need to be your research. I'm sure lots of you who are graduate students or undergraduates may have worked on research projects and it hasn't been your favorite thing, I'll be completely honest. But there are other things out there that excite you. I would say that if you know you have that interest, just start trying to read more about how that kind of field exists outside of the lab, and then find somebody who has done this that's local to you, or through NESSE, or you can email Jeff or I and just invite them out to coffee and ask them what they did. Like, how did they get to a point where they made that decision to start a business? And then the second thing is, if you are considering doing this and you have the opportunity through courses at your university, sign up for one, take it. Like there's no risk really to it other than your time, which is only going to be more costly the longer you wait. So take one of those classes now while you have this freedom. Hopefully you have the freedom to take some external classes, or if they're not at the university, there are workshops in your community or online. Because the longer that you wait to try and start a venture like this, the more excuses you may come up with for reasons not to do it. And that's not really what we want to see. We want to see, if you've got the idea, just act on it, and you'll be able to make a lot more progress than I think a lot of people initially think that they would. We certainly have been surprised by our own progress so far.
And I just want to add quickly that I think engineers and scientists are poised to be really good entrepreneurs because we ask a lot of questions and then use data to really solve those questions. So we've learned in taking business classes that there might be a textbook that tells you how to do fundraising or maybe like how to sell a product to a customer, but then it's kind of your job as a scientist or engineer to really challenge those assumptions and see if that's honestly the best solution for your business. So, I mean, every time we hear a piece of advice from even an investor or an advisor, we'll take that note and kind of we'll jot it down in a notebook. But then Tony and I and other people on our team will really challenge that assumption and see if it really makes sense for our business. So if someone gives you a piece of advice, even what we're saying right now, I would encourage all of you to really challenge that advice and like just use that as a single data point, an n=1 for that piece of advice, and really make sure that it's appropriate for what you're trying to do.
Brilliant. I think those recommendations were great, and I think this will, I hope that this will inspire more early career researchers. You know, if they have this dream of transforming their research, their business ideas, their research ideas into real business, go for it. Read more. Get explore the fact that as a scientist, we have this, as I said, the mindset of analyzing everything very methodically. We tend to be very careful with what we put in terms of forward in terms of results as reports, and use this in our advantage to gain more knowledge about the field and transform ideas into businesses that will contribute towards the bio-based economy and eventually help us achieving a more sustainable future. Jeff and Tony, I'd like to thank you very much for the opportunity of being here with you today. I know you guys have been very busy recently applying for grants and talking to customers, talking to people around you. So I really appreciate that you found some time to talk to us. Also, thanks Derek and Beyond Benign for the opportunity of using the platform and reaching out to people. And most importantly, thank you guys, the attendees who came and spent a bit of your time to come here and listen to us. That's a bit about what NESSE wants, to reach out to people and spread the message, incentivize people to, you know, look for developing their skills whilst having in mind the importance of a more sustainable future. So yeah, thank you very much, guys. And yeah, that was it. Do you guys have any sort of final words?
I just want to say thank you to you, Philippe, and Derek, for kind of providing the venue for us to do this. I've been kind of following what NESSE has been doing since they first announced, you know, a few years ago at the Green Chemistry Conference in Portland, and I'm just super excited to continue to see this grow. So I'm hoping that all the people listening on the call will also join NESSE, even if it's as much as just putting your email on the website and getting the newsletters, because I think the biggest things for us as scientists and entrepreneurs is the mentality that every single person that we meet knows something that we don't. And so, you know, every possible interaction is always a value add. So the more people that you can loop in your network now, especially as students or as, you know, early budding entrepreneurs, is gonna improve with outsized returns into what you can do in the future, because you'll just have that many more resources to pull on. So again, thank you guys for letting us be a part of the network and sharing back from what we've learned as well.
Yeah, brilliant. Thank you so much, Tony, for the kind words. And thank you, everyone, again. I'll just make the presenter again, because I'll just share the final slides here that we have. So for everyone who is interested in knowing more about NESSE and our network and what we have to offer, you guys can visit our web page. And again, follow us on social media. So we are on Twitter, on Facebook, Instagram. So you can look for us and interact with us. And we, as I said, this webinar will be available to be seen later. So I do encourage you to share with your friends. If you have someone that you're thinking that has, research idea that wants to become the new entrepreneur in the block, so feel free to share with them. If you guys have any questions, later questions for Tony and Jeff, please get in touch with us, with NESSE, and we'll be putting you in touch with them. And as Tony said, we do encourage this interaction between people, because as a network, we believe in the power of interaction and the power of exchange of ideas. And yeah, that's one of our core values. So thank you very much once again, everyone, for the opportunity. I'm hoping to come back to you with news about new webinars pretty soon. So stay tuned on what NESSE has to offer. Thank you all again. And yeah, that's pretty much everything for today. So yeah, NESSE would like to thank you all for attending today's webinar, and I see you next time.